Hello, my name is Danesh Shamsi, and this is my extra credit video concerning the lecture I attended for physics. The lecture I attended was called What Happened Before the Big Bang. The speaker was named Martin Bojuwald, Dr. Martin Bojuwald, and overall, this topic interested me because of my desire to learn about the possible beginnings of the universe itself. I mean, who isn't really interested in that? Overall, the lecture was incredibly advanced in terms of the mathematics that was discussed, and the majority of the lecture was a discussion of the mathematics that could potentially answer this question. And funnily enough, one of the main things I learned from this lecture was that the quantum mathematics of that they were using, that this kind of stuff even exists. I honestly had no clue that math this advanced was actually utilized. And without a doubt, it was very in-depth, and a large amount of quantization was actually used throughout the lecture. And because of this lecture was directed towards people with a great deal of knowledge about quantum mechanics, I had to learn about what quantization actually was first. So, quantization is the process of explaining a classical understanding of physical phenomena in terms of a newer understanding known as quantum mechanics. By quantizing a number of advanced physics concepts, a basic path by Dr. Bojuwald was created to answering the lecture's main question. Additionally, an important relationship between general relativity and spatial relativity was shared. We've learned about relativity in our physics class itself. General relativity states that space-time is dynamical, that it can expand, and it affects matter and is also influenced by other matter. Special relativity states that space and time are not absolute. So, while the majority of this lecture discussed the advanced mathematics behind all of this to explain what could possibly happen before the Big Bang, I learned that during the Big Bang, time itself did not exist in this dense space-time. So what did happen before the Big Bang? Unfortunately, this was never actually answered. It was all the math and quantization led up to this not actually being answered because it's still unknown. However, key concepts about what was occurring during the Big Bang was discussed, and that interested me a lot. Dr. Bojuwald called this Big Bang state the state of hell. This means that there was theoretically no spatial expansion, maximum ignorance, and my favorite part, or concept even, is really a concept, is infinite temperature. The state of hell really assists in explaining the fact as to why there is no intense growth in entropy during the Big Bang, because you would think that during the Big Bang so much energy would be lost to entropy. Well, following up on this lecture, I decided to look up more about the concept of infinite temperature itself, because that interested me the most. And seemingly enough, not much is known about it, because it is a pretty wild concept. However, theory and laws of thermodynamics cannot rule out this concept, and that's what makes it a part of the state of hell that was previously explained. So overall, a good bit was learned about quantum mechanics in this lecture, and it definitely opened my eyes to some physics that I didn't even realize was done. It was pretty fascinating, and although it was way over my head, I genuinely enjoyed watching Dr. Bojuwald's lecture.